Hello guys and welcome back to the channel. Today we're going to be going through a GCSE Physics worksheet targeted at those students that are looking for a grade 6 to 9 in GCSE Physics.
The next question tells us that a car accelerates from 5 meters per second to 25 meters per second in 4 seconds, and it's asking us to calculate its acceleration. Well, first of all, we can write down the quantities that we already have. So we know that the car accelerates from 5 meters per second to 25 meters per second, and it does this in 4 seconds. So t equals 4 seconds. So here we could use one of Newton's suvat equations to solve this. So we can write out suvat and fill it out for everything we've got. We've got u, the initial velocity, which is 5 meters per second, and we've got v, which is 25 meters per second, the final velocity. We've also got time, which is 4 seconds. We don't have displacement s, and we're working out a, which is the acceleration. So we've got u, v, and t, and we're working out a. What equation could we use it? We could use v equals u plus at. Of course, we're trying to work out the acceleration, so we have to rearrange this to work out a. So we can do a equals v minus u over t. Now it's simply just putting in the values that we've got. So a equals 25 take away 5 over 4. So 25 take away 5 equals 20, and then 20 divided by 4 equals 5. So we have now worked out the acceleration, which equates to 5 meters per second squared. The next question asks us to explain the difference between mass and weight, and also to include the equation for weight. Okay, well, let's do mass first. So mass just means the total amount of matter in an object. So that's mass, the total amount of matter in an object. Now, as for weight, weight is the force created by the mass of an object due to gravity. So the equation for weight would be W equals mg, where W equals the weight, m equals the mass, and g is the gravitational field strength, or just the force of gravity, which on Earth is 9.8. The next question asks us to draw and label a velocity time graph for a car accelerating, cruising, then decelerating. Okay, so let's draw the velocity time graph. We do this where the velocity is on the y-axis and time on the x. So first of all, let's do the car accelerating. So that would just be drawn like this, where it's just a straight line with a positive gradient showing that the car is accelerating. Now for cruising, there'd be no gradient, as the car would be in constant velocity as it's cruising. And then finally decelerating, where it'd be a straight line with a negative gradient. So if we just label it that, accelerating, this is where the car is cruising, and this is where the car is decelerating. Question 5 tells us that a resultant force of 30 newtons causes a 10 kg object to accelerate, and we're asked to calculate the acceleration. Well, here we can use Newton's second law, which is the equation of F equals ma, where F is equal to the resultant force of the object, m is equal to the mass of the object, and a is equal to the acceleration of the object. So we know that F equals 30 newtons and m equals 10 kg. So we can just put that into the equation. So 30 equals 10a. Now we have to work out a as well as to calculate the acceleration. So how would we do this? Well, we just divide it 30 by 10 to get both sides by 10 to get a on its own. So then we'd get a equals 30 over 10, which is 3. So the acceleration is equal to 3 meters per second squared. The next question wants us to calculate the gravitational potential energy of a 7 kg object raised 5 meters above the ground using g equals 9.8 meters per second squared. So this, we're asked to work out the gravitational potential energy, and we know that the equation for that is GPE equals mgh, where m is the mass of the object, g is the gravitational field strength, and h is the height. So in this question, we're given m as 7 kg. And we're also given h, the height, as 5 meters above the ground. So h is 5. So now we're also given g, which is 9.8 meters per second squared. So now it's just inputting these values into the equation to get GPE. So GPE equals 7 times 9.8 times 5, which we can put into the calculator. 7 times 9.8 times 5 equals 343 joules. And there we go, we've worked out the gravitational potential energy. The next question tells us that a 100 watts bulb is used for 2 hours, and we're asked to calculate the energy transferred in kilojoules. Okay, so let's write down what we've got. So we've got the power, which is 100 watts, and we've got the time, which is 2 hours. However, in physics, the unit for time is seconds, so we have to convert this into seconds. 2 hours equals 7,200 seconds. Okay, so the equation that links power, energy, and time is P equals E over T. However, as we're working out E, we know that we can just times P by T, so E equals the power times the time. So the energy transferred just equals 100 times 7,200. So E equals 720,000 joules. However, the question wants us to give the answer in kilojoules. So all we do is we divide this value by 1,000. So E is going to be 720,000 divided by 1,000 equals 720 kilojoules. And there we go, we've worked out the energy transferred in kilojoules. The next question asks us to define efficiency and also calculate the efficiency of a device that outputs 60 joules from 150 joules input. Okay, so first of all, we'll define what efficiency is. Efficiency is just the ratio of work done to the total energy input. So efficiency equals the ratio of work done to the total energy input. Now, as for working out the efficiency, well, the equation for efficiency is useful energy output divided by total energy input. So now let's actually work it out with the values we've got. So we're told that the useful energy output is 60 joules, so 60 as the numerator, and the total energy input is 150 joules, so 150 is the denominator, and then we just calculate this. So 60 over 150 equals 0.4, and that is the efficiency.
The next question asks us to define current, voltage, and resistance. So current is the rate of flow of electrons or charge, and the unit for it is amps or A. Voltage is the difference between 2 points in EPE or electrical potential energy, and the unit for this is volts or V, and resistance is a measure of how much a material resists the flow of electrons or charge, and that is measured in ohms. And that is how you answer this question. The next question tells us a 12-volt battery provides 3 amps of current and asks us to calculate the resistance. We can just plug these into the formula V equals IR, where V is voltage, I is current, and R is resistance. So we say that 12 is equal to 3 lots of R, divide both sides by 3 to give us 4 equals R, or the resistance. So you can say 4 ohms is the resistance. And that is how you answer this question. The next question tells us to compare the particle arrangement and energy of solids, liquids, and gases. So in a solid, the particles would look like this. They'd be tightly packed next to each other and they'd vibrate about fixed positions. In a liquid, it would look like this. So they'd still be pretty closely packed together, but there's more freedom, they can move around more. And in a gas, they would be few and far apart, and they wouldn't really be close to each other that much. And if you look at the energies of these, in a gas, the particles will have the highest energy because the particles are moving around the most. They have the highest energies, that's why they move around a lot. In liquids, it's less than gases because the particles are more tightly packed together, but there's still space for them to move around. And in solids, they have the lowest energy because the particles, they can't move about, they're in fixed positions, they only vibrate about their fixed position, so they have the lowest energy out of the 3 states. The next question tells us to define density and use the formula to calculate the density of a 500-gram object with volume 200 centimeters cubed. So First of all, if we're defining density, we can say that density is the mass per unit volume of a material or an object. And if we use the formula, which is density equals mass over volume, we can see that 500 grams at the top divided by 200 centimeters cubed, and these are the units that we use, grams per centimeter cubed. We can see that the density of this would be 2.5 grams per centimeter cubed, and that is how you answer this question. The next question tells us to explain the term specific heat capacity, or SHC, and its significance in heating materials. Well, specific heat capacity is the amount of energy needed to raise 1 kilogram of a substance by 1 degrees Celsius. And its significance in heating materials is that the higher the specific heat capacity of a material or an object, the higher the energy required to heat it by 1 degree Celsius, and that is how you answer this question. The next question tells us a 2 kg block is heated and its temperature increases by 10 degrees Celsius, and asks us to calculate the energy transferred if the SHC, or specific heat capacity, is 4200. So the way we can work out this is by using the formula energy is equal to mass multiplied by specific heat capacity multiplied by change in temperature, delta T, we can write for that. So if you just plug in the numbers we have, we can see that the energy is equal to 2, because that's the mass, 2 kilograms, multiplied by 4200 multiplied by 10, because that's a change in temperature. So we can see that E would be equal to 4000 times 10 is 8400 times 10 would be 84,000 joules, and that is how you answer this question. The next question tells us to describe the structure of an atom. Well, an atom has a nucleus with protons and neutrons, and it has outer shells of electrons, which we can represent with these X's. So this is how you would draw it, and we can explain this by saying there are shells of electrons on the outside, and the nucleus contains protons and neutrons, and that is how you would answer this question. The next question tells us to compare alpha, beta, and gamma radiation in terms of penetration and ionization. So in terms of penetration, I'll label that with P. Alpha has the lowest penetration, and it increases as you go across. So beta will have the next most, and gamma will have the highest penetration. And in terms of ionization, it's the opposite. So alpha has the highest ionization power, and gamma will have the lowest. And that is how you answer this question. The next question asks us, what is half-life? So for half-life, we can say that half-life is the time taken for a substance undergoing radioactive decay to reduce to half of its original state. And it tells us that a substance has a half-life of 3 days, and asks us how much remains after 9 days if the initial mass was 80 grams. So let's break this up. Let's say if its half-life is 3 days, so it started at 80, and in 3 days it becomes 40. So out of our 9 days, it's now 6 days left, and then that's what we want to know, the amount at the end of these 9 days. So, and then we'll go from 40 to 20 because it'll half again. Then there'll be 3 days left, and from 20 it will go to 10 grams, and there'll be 0 days left. So we can say that after 9 days, 10 grams remains. And that is how you answer this question. Thank you guys for watching this physics worksheet work through. Hope you enjoyed the video, and leave a comment letting us know what topics you want us to cover in the future.